Welcome to Brain Vision.
In this problem, we have a ball hanging from the ceiling at angle beta, and it's being supported by a horizontal string. Whenever the string is cut, the ball will swing back and forth between position A and position B, and the problem is asking for the ratio between the tension that this string experiences at position B with respect to position A. And so the strategy is to apply sum of the forces is equal to mass times acceleration at each point. Now, before the horizontal string is cut, this system is in equilibrium. The ball is just hanging and it's not moving at all. And so we know that the vertical component of the tension here must balance the vertical component of the weight, which is all the weight. And so applying this, sum of the forces is equal to 0 in the vertical direction at point A gives the vertical component of the tension, which I label as TA, is the tension on the rope at point A. And then to get the vertical component, I multiply by cosine of beta, beta being the angle from the vertical. And then this must be balanced by the weight, which I'm going to denote by, if my pen stops glitching out here, W. So W is the weight of the ball. Now at point B, we're going to do the same thing, except we have to balance the tension, the total tension, with the radial component of the weight. So now we're applying Newton's second law in the radial direction. At point B, though, there is no acceleration because the ball is instantaneously at rest. And so because of that, we still have this, because there's no acceleration at that instant. But we are going to apply this in the radial direction. And so the tension, the total tension in the radial direction is just going to be labeled, and my pen's glitching out again, by TB. And this must balance the radial direction of the weight, which is W times the cosine of beta. And so these two equations are when you apply Newton's second law here to the two positions A and B. The first one, we balance the vertical direction of the forces, and the second one, we balance the radial direction of the forces. But in both cases, the acceleration was 0, so we could apply this. Now all you do is you take TB divided by TA, and you see what you get. You get W times cosine beta over W over cosine beta. I just solved for TA there, so you divide by cosine beta. And then this simplifies, the W's cancel, and the cosine beta in the bottom comes all the way up to the top, so you get cosine squared of beta. And that's the final answer.